Here is the end of our solving rational equations lesson. So we've kind of broken it down into stages and kind of used varying sizes of problems and varying levels of work as we work our way through them. Now we're kind of getting to the biggest versions of them. So we're going to still follow the same steps. We start with our excluded values. What can't x be equal to? Well, in this problem, x can't be equal to 0, and x can't be equal to positive 2. Then we've looked for our least common denominator. What could I construct using all of the denominators put together? Well, I need to have an x, and I need to have an x minus 2. Remember those binomials, x minus 2, think of it as a whole term by itself. It kind of travels as a pact. I can't just take the x or just the 2 from it. So I'm going to multiply everything in the problem times x plus 2. So I'm going to do x times x plus 2 times 10 over x times x plus 2. Then I'm going to do x times x plus 2 times 4 over x. And x times x plus 2 times 5 over x minus 2. Now remember, the whole reason behind doing this is multiplying by that least common denominator. We're treating everything equally, so we're not changing the equation, but it is going to allow us to simplify these and get rid of our denominators. We're going to turn our denominators into a 1. So for instance, on the first term, I can divide an x on a numerator and denominator. I can divide an x plus 2, and I'm just left with 10. For my middle term, I can divide out an x from numerator and denominator, and I'm just left with 4 times x plus 2. For the last one, that should be a, I miswrote it here. It was supposed to be an x minus 2 when I wrote it out there. Sorry, I got carried away there. So x minus 2, so I can divide an x minus 2 out of each of them, and I'm left with 5x. So now I simplify it, so I get 4x minus 8 is equal to 5x. I can subtract my 4x to the other side, and I get 2 is equal to x. Now, my last step is always to go back and check my solution. So I'm going to plug 2 back into my problem. So I have 10 over 2 times 2 minus 2 plus 4 over 2 is equal to 5 over 2 minus 2. Well, two things should occur to you right now. One is 2 minus 2 is going to give me a 0. 2 minus 2 is going to give me a 0 times 2 is still 0. So I'm going to get a 0 in my denominator. So clearly this answer is not going to work out. But if we look back at our excluded values, it told us that. It told us that if we get x equals 2 as an answer, that cannot be one of our answers. So we would say x equals 2 is an excluded value. Okay? It can't be one of our solutions because it's going to cause that 0 in that denominator. All right, example number 5. So, only thing different in this one is look at that right-hand side of the equation. Notice we have x squared plus 2x. That's not in factored form. So before I can even decide on my excluded values, I need to factor that into its pieces. So x squared plus 2x is going to become x times x plus 2. I'm going to factor that out of it. Now I can choose my excluded values. That's going to be x can't be 0 and x can't be negative 2. So remember, it's got to be in factored form before we can decide on those excluded values. Then for my least common denominator, basically think of it as I need something that will cancel out or divide out all of the different parts of the denominators. So I need to be able to divide out an x and an x plus 2 out of various pieces. So I'm going to multiply everything in the problem times x plus 2. So I'm going to do x times x plus 2 times 1, and then x times x plus 2 times 1 over x plus 2. And then I'm going to do x times x plus 2 times 28 over x plus times x plus 2. Leave that in factored form, that denominator, because we want to see which of those pieces we can divide out. Well, in the first term, I'm just multiplying by 1, so I get x times x plus 2. Here I can divide out an x plus 2, and I'm left with x. And my last term, I can divide out an x plus 2 and an x from numerator and denominator. I'm left with 28. So I get x squared plus 2x plus x equals 28. If I combine everything and move it all to one side, I'm going to get x squared plus 3x minus 28 is equal to 0. Since it's a quadratic, since it has a squared term, I know I'm going to have to factor. So what multiplies to give me 28? But since it's subtracting, I know they have different signs. So what's going to subtract to give me 3? Well, that's going to be an x plus 7 and an x minus 4. So x is equal to negative 7, x is equal to positive 4. All right, so now we have to check. So I'm going to do 1 plus 1 over x plus 2 is equal to 28 over x squared plus 2x. So I'm going back to that original version of the problem. Okay? Well, I've got 1 plus 1 over 5, and it's going to be a negative. And then I have 28 over 49 minus 14. Well, 1 plus negative 1/5, well, that's really 5/5 plus negative 1/5 is 4/5. 28 over 49 minus 14, well, that's really 28 over 35, which if I simplify, it gives me 4/5. So that one works. So let's check our other one with a 4. So I'm going to do 1 plus 1 over x plus 2 is equal to 28 over 4 squared plus 2 times 4. So I get 1 plus 1/6 or 5/6. Here I get 28 over 16 plus 8 or 28 over 24. 28 and 24 can be each divided by 4, and I get 7/6. Oh, and I forgot over here. This was 6/6 plus 1/6, which is 7/6. So I did get it on the same side, so I am good. All right, one last problem. We're going to skip number 6. It's pretty simple. It's very similar to what we did last week, so one of our more basic ones. So we're going to go down to the bottom one, number 7. Okay, and you'll notice that these problems take a lot of work. So I don't have anything to factor in my denominator, so I can go right to my excluded value. That's going to be x is not equal to 2, and x is not equal to negative 2. My least common denominator is going to be both of my pieces, x minus 2 and x plus 2. So I'm going to multiply that times my entire problem. So x plus 2 and x minus 2 times 2x minus 5 over x minus 2. And then x plus 2 and x minus 2 times 2. And then x plus 2 times x minus 2 times 3 over x plus 2. So the whole point of this step is to rationalize that denominator, get rid of those denominators, so we're just dealing with whole terms. So here I can divide out an x minus 2, and I get x plus 2 times 2x minus 5. In this middle one, I don't have anything I can divide out, but what I have to watch is that negative. So we don't want that negative to get lost, because otherwise you're going to think you're just subtracting the first part of the next term. We really want that negative to travel through the whole thing, so I'm going to change it to adding the opposite, and I'm going to put the negative on that 2. So this is really negative 2 times x plus 2 times x minus 2. And then the other side, my x plus 2 cancels out, and I have 3 times x minus 2. Okay. Now it's just a whole lot of math. So multiplying out the first one, I'm going to get 2x squared. I'm going to get a 4x in the middle, but a minus 5x on the outside. So that's a minus x, minus 10. Here I'm going to get x squared plus 2x minus 2x minus 4. So those middle terms are going to drop out. But then I got to multiply by that negative 2. So that's going to give me minus 2x squared plus 8 is equal to 3 times x minus 2. Oh, sorry. Forgot to multiply that part out. That would give me 3x minus 6. My x squareds are going to drop out. I'm going to add my x to both sides, and I'm going to add my 6 to both sides. So negative 10 plus 6 plus 8 is positive 4, and 4x, so x is equal to 1. Last part, do a quick check. So 2 times 1 minus 5 over 1 minus 2. Minus 2 is 3 over 1 plus 2. 2 times 1 is 2, minus 5 is negative 3. 1 minus 2 is negative 1. Well, negative 3 over negative 1 is really just 3 minus 2. The other side is 3 over 3, which is really just 1. 3 minus 2 really is 1. So just some more elaborate problems, more steps involved, but it's the same process. Find those excluded values, find that least common denominator, multiply everything with the least common denominator to rationalize those denominators, and then we just solve it like we normally would.